The switch circuit is our focus today, and I want to mention that this is a very important circuit for the logic gates, because if you want to test any logic gate like the NOT gate, the AND gate, or the XOR gate, or any other logic gate, you need to provide an input, and the input can be provided by the switches or the switch circuit. So let me start with drawing this circuit, and then let's see how can we connect it by the hardware. First of all, I want to explain its connection, and I just want to mention the normal connection, and then I'll explain another simple connection. So this is how it looks like. We connect a battery, the positive side of the battery, to the first pin of the switch, and the second pin of the switch to a resistor, and this resistor can be 1 kilo ohm or less. It cannot be more than this, and I'll show you an example. And then from the resistor to the second pin or the negative pin. And our output will be from this point. Okay? The output of this point will be either 5 volts or 0. And logically or theoretically, we say 5 volt is equal to logic 1, and 0 volt or the ground is equal to logic 0. So I need you to differentiate between the theoretical logic values and the actual hardware values. So if we close this switch, then this point will be directly connected to the positive side of the battery, and the positive side means 5 volts. Okay, and if we open this switch, this is gonna be an open circuit, which means that this point is connected to the ground. You might say we have a resistor here. Yes, that is right, but the voltage on this circuit will be 0, because we know that the voltage is equal to I, the current, multiplied by the resistor value, and we have no current here because the circuit is an open circuit. So this will be equal to 0, and that means that this seems to be connected to the ground. So in this case, we will have 0 volt. Okay? So again, when we close this switch, then we have 5 volts. When we open this switch, we have 0 volt, which is equal to logic 1, and this is equal to logic 0. That is good. But I just want to mention another thing, which is the normal connection that all people use. So we can draw something like this and write VCC, and then this is our switch, and this is our resistor, and this is the ground. And the point here, this one is our output. So this one is exactly equal to this one. But this is how people used to draw the switch circuit, and if you search on Google or any other search engine, you will find this this drawing or this graph here. So now let's connect this by hardware. We need a switch, resistor, and battery or a power source. First of all, let me show you the power source that we have. As you see here, we have this power supply. It provides 5 volts, and we get the 5 volts from these 2 pins. And we have here our test board. As you can see, the test board has some connections like the blue and the red ones, and these blue and red ones are used to connect all positive and negative values, or the VCC and the ground, in the circuit. So for example, we know that these 2 lines are separated from these 2 lines. So we use these 2 connections or wires to make sure that this one is connected to this one, which means the ground will be here in the whole line, not only on the left, on the right or the left side. The same applies to the VCC. How do we know that this part is separated from this part? You can look at this one. I don't know if you can see it. Let me zoom in a little bit. So you can see that these two lines are not connected together, and the same applies to the blue ones. Yeah, you can see it from here. So, and also we need to connect these two lines to these two lines. That's why we have the blue and the red lines. Okay, let's start connecting the switch. This is our switch. I hope that the camera focus is working fine. And on here, we have 4 switches, not only one. So we need to make sure, let me make sure that it can be shown. Yeah, as you see. So we have 4 switches, 4 pins on one side and the other 4 pins on the second side. We need one switch, right? So I am going to take this pin and this pin. Okay, the first pin on the right. Again, yeah, the first pin here and the first pin here. Let me start by connecting this here. Okay, and we have to connect the first side here and the second side here. We cannot connect it like this because that means that the 2 pins will be always connected together, but we need to separate them on different sides. So I'm going to connect the switch like that. That means we finished this part. We need to take the first pin and connect it to the VCC. So I'm going to go to the upper pin and connect it to the VCC. Let's take this line. This is just a simple wire, and connect this point to the VCC. That is good. So we finished the upper part. Let's focus on the second part, the lower part. We need to connect a resistor from the second pin, the lower pin of the switch, to the ground. So I am going to bring a resistor. This is our resistor here, and then from this part to the ground. Okay, so that is our connection, and now we need to test this, but we have to connect the power supply, right? So this is the VCC and this is the ground, so I'm going to connect this to the VCC and this to the ground, and that's it. Before testing the switch, I need to ask you, how can we measure the output? We need to see the output. We know that when we click on the switch, we will get 5 volts, and when we turn the switch off, we will get a 0 volt. So to do so, we need this voltmeter or multimeter. So I'm going to open the multimeter and put it on 20 volts. So this is our multimeter. And by the way, you can see the output by connecting an LED here, or LED. Okay, so I'm going to do both, but let's start with the voltmeter first. So I'm going to connect this to the ground, this part to the ground here. Where is the ground? This pin. And this pin will be connected to this pin. Why I am connecting here, not here? Because if you put this here, then you are always connected to the VCC. But we need from this pin, exactly like we do here in this picture. By the way, I know that I am explaining in details, but I know that most people are not aware of the hardware, and that's why I am explaining every step. So we need this to connect, to measure the output from this pin, not from this pin, because if you put your multimeter here, you will measure the VCC. So our switch now is off. So I'm going to connect this to the ground. Do you see the ground here? And then I'm going to connect this to here. So the output on the voltmeter is 0. Let's do this. Oh, we do not have output, right? So we do not have any output. You might say, oh, but this is the ground, and you are measuring the output by the ground. It doesn't matter, because it can provide negative 5 volts or 0. But if you measure again, it is still 0. If we turn the switch on, it is still 0. The first step to diagnose your circuit is to measure the power supply output. So we need to come here, and here you can see that we have 0 volt. So the power supply is not working. although you can see that the power supply has an output 5. The reason for that is this power supply has a pin to turn the output on or off. Although you can see the 5 volts here, but it is not gonna work unless you click this output here, this output pin. So now we are ready to work. The first thing that I'm going to do is measuring the power supply. Do you see? It is almost 5 volts. And then let's connect this to the ground and measure here. You can see that it is 5 volts. That is because the switch is on. When we click this here, you can find that the switch is off and it is providing 0 volt. Again, click on this. It should be 5 volts. Something is wrong. Yeah, it is 5 volts. I just need to connect this well. Again, click, turn the switch off, turn the switch on. The switch circuit is working fine. Now, let's connect an LED, okay? By the way, the large part inside, I don't know if you can see, the large part inside is the negative value, the negative side. So what we need to do is to put a resistor here, and then an LED to the ground. The resistor should be between 22 ohm to 33 ohm. I'm not going to explain electronics here, okay? So I'm just explaining how to connect, but I'm not going to explain why this. But if you want to know, you can you just know that we have 5 volts here, 0 here, and this LED works by 2 volts. So this volt minus this volt over the resistor, you can get over the current that this can take. Because if you search online, you will know how much current this takes and how much volt it works on or it uses. So 2 volt and some current. So you have the volts and you have the current. You can just divide both and get the resistor value. That is a quick explanation. So what we need to do is to just from this pin add a resistor 22 ohms. I don't remember if this resistor is 220. Sorry, 220. And then let's connect the LED. This is our resistor connection. Let's make sure that we are connecting this resistor well. And then we have the LED. The positive part should be connected to the resistor, and the second part should be connected to the ground. Okay. Then we need to make sure it is working, but it is not working. So I am going to bring a resistor 220 ohm and then come back. Okay, this is a 330. Okay, so now we have our circuit, but it is still not working. So I'm going to remove this LED and bring another one. This is how we diagnose our circuit. And then put this one here and turn the switch on. You can see that it is working, okay? Why do we need all of this? Because if you have a NOT gate here, you need to provide a 0 or 1, right? 0 means 0 volt, 1 means 5 volts. That is why we need the switch circuit, and that is all what we needed to explain about the connection of the switch circuit. I hope that this was easy for you. In the next videos, I'm going to explain how to connect some logic gates like the NOT, the AND, and the XOR gates. That's all for today, and see you in the next video.